How did the Milky Way come to be? How did it evolve through a series of incredible events into the galaxy we call home today? And how will it eventually meet its end? In its story, we also discover our own role, because the Earth we live on lies within the Milky Way, right in the middle of one of its magnificent spiral arms. Our planet orbits a small, familiar star. In a way, the Milky Way is like an island. Every single star we see in the night sky is part of our galaxy. The nearest major galaxy is over 2 million light-years away. So it's easy to feel like we are alone, drifting in a dark ocean, and in some ways, that's true. There's no realistic technology humans can even imagine that would truly let us leave this island. But science allows us to dream. To imagine leaving our galaxy behind and seeing the Milky Way from an impossible point of view. Final countdown starting now. 8, 7, 6, 5, 4, 3, 2, 1, 0 ignition. We began a mission unlike any before, one that's deepened our understanding of the Milky Way in ways we never thought possible. This space probe, named after an ancient Greek goddess, is performing flawlessly. It's called Gaia. Booster separation confirmed. Gaia represents the mother of all life on Earth. 4 thrusters successfully detached. Gaia's mission: to map billions of stars across the Milky Way, most of them for the very first time. The Gaia probe rotates on its own, scanning the entire galaxy in every direction. Each star it measures gets scanned about 70 times on average. That lets Gaia calculate each star's speed and direction, pinpointing its location with mind-blowing accuracy, down to 1/100,000th of an arcsecond. It scans over 1.5 million stars every single hour. So far, it's mapped nearly 2 billion stars. That's absolutely unprecedented. Thanks to Gaia's data, we can create the most detailed star chart ever made. This is a revolutionary leap in exploring the Milky Way. This image, built from Gaia's data, looks like something from an artist's imagination or a sci-fi movie. But it's real, a high-precision, three-dimensional view of our home, our island of light. We can even use it to travel across the galaxy. The positioning is incredibly accurate. Every one of these points of light is a star, some as far as 30,000 light-years from our solar system. This star map lets us fly across the Milky Way faster than we ever could in reality, getting to know incredibly distant stars. It's also a trip through time. What's really special about this map is that it's dynamic. Gaia didn't just measure where the stars are, it also measured how they're moving. That means we can figure out their paths, predict the future of the Milky Way, and even work out where they used to be and what our galaxy looked like in the past. By tracing the motion of each star, we can wind back the clock billions of years. The earliest galaxies formed just a few 100 million years after the Big Bang, inside a vast cosmic web woven across space. Huge filaments of dark matter created gravity that pulled gas together, leaving enormous empty voids between clouds of nebula. The first stars were born at the intersections of these dark matter filaments, where gas became so dense it collapsed under its own gravity, triggering massive change and igniting stars. Billions of new stars flared into existence. Pulled together by gravity, they formed the first galaxies, including a young, still forming Milky Way. Today, our galaxy is a classic spiral. But back in its youth, it was smaller and much more irregular. The exact details of its birth are still being studied. But with modern astronomy, the story of how it grew is becoming clearer. Gaia's data lets us glimpse that evolution. One clue from this animation reveals a fascinating history. While most stars orbit the galactic center in neat, regular paths, exactly what you'd expect, there are others with wild, unusual orbits. They seem to be flying all over the place. That tells us something major happened as the Milky Way was forming. Across the whole universe, hundreds of billions of galaxies took shape. Dozens of them formed relatively close to the Milky Way. They gravitated toward each other, eventually grouping into what we call the local group, our own archipelago of star islands. 6 billion years before Earth formed, some stars in the Milky Way already had planets of their own. Those early worlds were about to witness galactic evolution. What's amazing about astronomy is that even when we can't see those planets, we can still imagine their stories. Look over there, near the bright star Vega, that's Kepler 444, a faint ancient star with planets. It's seen almost the entire history of the Milky Way. When you look up at the famous Big Dipper on a clear night, follow it down toward a very dim star, one too faint to see with the naked eye. It's so ordinary it doesn't even have a real name, just a number, HD 73394, a star from outside the Milky Way, born in another, smaller galaxy. When that galaxy collided with ours, this star was pulled in. And Kepler 444 was there to see it all, witnessing the moment our galaxy was thrown into chaos. Kepler 444 has 5 planets. In their skies, things happened that had never been seen before. A smaller galaxy was moving closer to the Milky Way, its stars shining with bright blue light. The Gaia Enceladus galaxy, a member of our local group, was about 1/4 the size of our Milky Way. The collision between these two galaxies took hundreds of millions of years. Stars from Gaia Enceladus plunged deep into the heart of the Milky Way. Our galaxy withstood this invasion and captured countless intruding stars. The whole Gaia Enceladus galaxy was swallowed up by the Milky Way. Many of those foreign stars are still here today. Gaia's data shows us that galactic collisions are a driving force in how galaxies evolve. After a collision, some galaxies stop existing as independent islands of light. Others grow, thrive, and get stronger. Survival of the fittest definitely applies out here. When we say galaxies collide, it might sound like a Hollywood disaster movie with stars tearing each other apart, but that's not how it works at all. Think of it this way. If our sun were a pebble or a grain of sand, the nearest star in our galaxy might be somewhere way over in those mountains. Stars are extremely far apart. They don't crash. So when galaxies interact, stars get scattered around, shapes change, but nothing really gets destroyed. Sometimes, a galactic collision can actually become an engine for creating new celestial objects. Make sure to hit that subscribe button, give this video a thumbs up, and share it with your friends and family. Thanks a bunch.